My name is Stephen Brobst. I'm Chief Technology Officer at Teradata and an advisor for 10x AI. And I'm very happy to be here at Deft Huang Insights. So what I'm going to talk about today is really more about social issues than technology issues. We'll talk about technology, but as participants in the field, we have a responsibility, an ethical responsibility to understand the impact of what it is that's going on around us and how the work that we do impacts other people. So this is the motivation for creating this talk for me. So if we look at AI, artificial intelligence, it is the buzzword of this decade, clearly, right? Gartner did a study, and they are predicting that AI is a top 5 investment priority for 30% of CIOs. And I will tell you, at least the companies that I work with worldwide, it's a top 3 priority, and it's much higher than 30%. At least 50%, probably higher than that, of the CIOs are thinking about how are they going to use this technology in order to sort of transform their business models. And so the problem with these new buzzwords is that they get overhyped. And this chart here shows what's referred to as the hype cycle. It's kind of a stylized version of the hype cycle from Gartner. And when new technologies get introduced, they start at the bottom of this hype cycle, and consultants and technologists and salespeople, they hype the technology. This is the greatest thing since sliced bread because they're trying to sell the technology. And expectations go higher and higher and higher, right? And you reach this point, which is the peak of overinflated expectations, where they've completely oversold the technology. It happens every time. And then you wake up in the morning, you say, you know what? Those consultants, those salespeople, they lied to me again. It doesn't do everything that they said it would do. And then what happens is you sink to the trough of disillusionment. We say, this stuff is terrible, throw it all away. I'm disgusted by all this overselling stuff. I will tell you that big data is now in that spot. In Silicon Valley, we don't use this term big data anymore. It's like a bad phrase, right? Because in the overhype of Hadoop, a lot of people think Hadoop and big data are kind of synonyms. The expectations were set too high. People were dumping tons of data into Hadoop and not getting any value. And they're annoyed by that. Gartner did a study that said 90% of Hadoop implementations delivered 0 value. It's not just didn't get good return on investment. 0 value is much worse than that. It means we spent a lot of money and we got no value. Spent our human resources, our money buying servers and so on, and IT is dumping data. No value. And there's a longer discussion we can have about why that happened, but a big piece of that is this mentality of data as an asset. This phrase I hate. Because what do you do with assets? You collect them, you put them in a warehouse, and you measure success by how big is it? How many bytes in the warehouse? How many assets do I have? And the number of bytes you have in a warehouse is a good measure of cost. It's a terrible measure of value. And so we need to think about data as a product, not data as an asset. So that's another whole big discussion. I'll touch on it again in this discussion, because in the end, data is the fuel for AI, right? But if you notice on this chart, artificial intelligence is like off the slope. That means the crash down is going to be even harder. It's a longer fall from here than here. And it's going to be painful. There will be broken legs, right? And part of the problem is, what does AI even mean? Robotics, and now you have RPA, and you have deep learning, and all these things are AI. Everything is AI. Every vendor claims whatever they're doing, it's AI. If you're a startup company, you put AI in your prospectus, the venture capitalists, they're throwing money at you. Right? So we've incented this, I'll call it bad behavior, of overhyping this term of AI. So for our purposes, I'm going to define AI in a more narrow way as deep learning. Using data to predict the future. Using data to prescribe actions that will improve the future. These are the definitions that I'm going to use in our discussion. So who gets to define what is AI? One of the problems is that the average person, their definition or opinion of what is AI comes from Hollywood, right? It's not Wikipedia. That's what some people say. Where do you get the definition of AI? I go to Wikipedia. Yeah, you're smarter than the average person. Most people just get it from television and movies. They think Skynet's going to take over the world, right? And there's a lot of movies out there, and most of them are dystopian, that AI is kind of doing weird things to the world, and there will be some weird things that happen. Actually, one of the earliest movies about AI, called Metropolis, was actually positive. It actually talked about how AI and humans would actually coexist, and that's going to be my focus. Now, AI does have some pretty amazing superpowers, right? AI can handle more data than any human can possibly handle, right? By using advanced computing with GPUs and some of the new algorithms like convolutional neural networks, we can handle more data and more dimensionality of data than a human could possibly do. And that dimensionality is important because it means we can look at many different angles of what the data is telling us. Humans, if you get beyond 3 dimensions, becomes very difficult for them. And of course, we can learn faster, right? With advanced computing, we can learn faster than humans can learn, and process decisions faster than humans. How do we define AI? One definition is, can machines think? The answer to that question is no. Machines do not think. A more interesting question posed by Alan Turing, who is a mathematician who lived in England, and he did amazing things in sort of helping us understand what this AI stuff means, even before AI was a hype term. And his question was, can machines do what we as thinking entities can do? It's a slightly different question than the first one. The answer to that question is yes, sometimes. So the question that I'm going to pose is, what do those things look like? And I'm going to suggest to you that any decision that a human makes in 5 seconds or less will be made by AI in the future. It's a pretty big statement, right? So why do I frame it in that way? Because decisions which are creative, strategic decisions, you don't make in 5 seconds. That requires more thinking and association and so on. But for example, driving, the decisions you make to put your foot on the brake, to change lanes, these kind of decisions are almost always made in 5 seconds or less. Those decisions will be made by AI, not humans in the future. So I taught my nephew how to drive, and I will tell you from that experience, humans should not be allowed to drive. He made the same mistakes that I made when I was 16 years old. Each human has to learn on their own, right? And this is inefficient. The AI, once you learn it, you got it. And AI doesn't text while it drives. AI doesn't fall asleep while it drives. Pays much more attention, doesn't talk to the friends while it drives. It's safer. And so in the future, AI will make these kinds of decisions. But there's some implications to that we're going to come back to. What is the implication when AI is doing the driving, right? Because there are societal impacts that we don't necessarily think of, because we think, oh, that's great, that's very convenient, I don't have to drive, we can just tell the car where we're going and so on. What about all those people who drive for a living? What about all those Korean drivers out there that now don't have a job? So in the US, more than 50% of males with no college education drive for a living. They drive Ubers, they drive forklifts, they drive trains, they drive delivery trucks, they drive many things. These jobs are all going away. What are those people going to do for a living? All right, so this is a very important societal question. We're going to come back to some other examples about this as well. So if we go back to 2010, the AI performance, in this case image recognition, was much worse than a human. If I take an X-ray image of a person that we're trying to diagnose, do they have cancer? A doctor, an expert doctor, will look at the image and diagnose and get it right 95% of the time. That means 1 out of 20, they get it wrong. That's why I suggest you always get a second opinion, by the way. Right? 1 out of 20, they get it wrong. An AI algorithm doing the image recognition, looking for the patterns of the disease, will get it right 98% of the time. So I want my next doctor to be an AI program, right? But if the doctor, human doctor, and the AI work together, they get it right 99.5% of the time. So if we use the AI to identify these are the risk areas, please, doctor, pay attention to these particular areas, and doctor, you get to make the final diagnosis. 99.5% accuracy. So this is better, right? So we don't necessarily always want to replace the human. In some cases we do, like self-driving cars in the future. We can't quite do it yet. Right? Mainly that has to do with policy issues more than technology issues, right? But there are cases where, humans do occasionally still add value, right? And we need to sort of figure out what the model is for different kinds of AI. This AI is going to be the basis of the fourth industrial revolution. So I talked earlier about the, people driving cars for a living. Those jobs are going to go away. We've seen the same thing in the third industrial revolution, where we replaced humans with more factory automation. For example, in the automotive industry in the US, there are almost no humans in the factories anymore. It's completely automated. Not completely, there's still some humans. But most jobs in those factories went away. Those people had to find new jobs. What did they do? They went and became Uber drivers. Or they went into other industries. So we're going to have to, again, deal with that. And you can't take someone who doesn't have a college education and make them a data scientist. Of course, we need more data scientists, but you have to have a certain educational foundation and a certain set of interests and so on. So there will be other things, and we will find jobs. And there's a lot of discussion in the industry right now. So is AI going to create more jobs or destroy more jobs? Because it does some of both, right? Because it creates new opportunities. There's more data scientists, more people working in IT industry and technology and programmers and so on. But that's a certain set of jobs with a certain set of skill sets. And then there's going to be jobs that go away with different set of skill sets. And I'm using the self-driving cars as an example, but it's cashiers in stores. Cashiers will go away. It will be self-checkout. And we'll use image recognition to make sure that people are actually checking out everything they do with, and the fraudsters are very sophisticated, right? They will scan something and they will change the sticker on the product and get something much cheaper. So I take some expensive pharmaceutical and I put a sticker from bananas on it, right? And it requires some cleverness because we also look at all the items scanned, and your basket is on the counter on a scale, and we look to see, are the items weighing the same as what the items that I scan? So we can do things like that, but criminals are very sophisticated. They will figure out, what product at a low price weighs the same as the product that I'm trying to buy at a discount price. But with image recognition and this weighing, we can figure this out, and we will eventually get to pure self-checkout, right? Customer service. We will replace call centers that have humans answering phones with chatbots. So today, if you go to, for example, Dell, you're chatting with someone saying, oh, how should I configure this laptop that I want to buy, and so on. You think it's a person. It's not a person. Now, if the discussion gets very complicated, it might switch to a person, and you don't even know it. But most of the time, 90% of the questions can be asked by AI software with natural language processing and good knowledge database. We can replace all those people, right? So those jobs just went away, right? The jobs, in telemedicine, right? You can have a chat bot giving you advice on, your kid has a fever and they have this symptoms and so on. Again, we can replace some of those things. Now, I'm not saying replace for everything, but the easy cases that happen over and over again, which is 80, 90% of the time, these things we just replace. So this industrial revolution will impact every industry, right? So what are we going to do with those people? Well, there's a couple of things. One is, in the US, we work a lot of hours. In Silicon Valley, if you're not working at least 50 hours a week, you are a slacker, right? And is that the best thing for quality of life? Would you rather be working 50 hours a week or spending time with your family 50 hours a week, right? So we can rebalance a little bit because I can do the hard stuff that humans are good at and let the AI do the stuff that I don't want to do. Let them do the repetitive stuff, right? And that improves my quality of life. Now, the caveat is that only works if you don't reduce my pay. So the stuff that I'm doing is higher value, so there needs to be a kind of pay scale adjustment. It's not per hour, it's for value. So I work fewer hours, but I make the same salary. Now, if you put someone out of a job, they say, well, we can't have people out of a job and not paying their rent and not being able to buy food and so on. So there have been some experiments of kind of minimum sustainable income. We can tax the companies, the AI companies or the companies using AI, tax them, redistribute that money, and give it to the people who are no longer working. They tried an experiment in Finland, and it's a disaster. If you just give people money, yeah, they can pay their rent and buy food and so on, but they don't feel purpose. And so you have to get the right balance. If we look at what AI is good at, it actually turns out to be relatively narrow decision making. Narrow decision making where, again, these decisions in less than 5 seconds. If you ask AI for strategy discussion, not a chance. AI is not good at creative things. AI is not good at art. They did an interesting experiment where they said, can we use AI to create a hit song? And they took the #1 songs for the past many years. That's the training set. Let the AI look at all those songs and figure out what really makes a good hit song. They produced one. Terrible. You would not listen to even 30 seconds of it before you shut it off, right? So there's, a lot of hype about AI, but the reality is generalized ability to reason and think is very far away. Yes, conceptually we can conceive of it. Hollywood is very good at projecting forward, but the reality is it's really targeted use cases and automated decisioning that we're mainly focused on. So again, what is AI? We use this term artificial intelligence as this big umbrella, but I think there's an important distinction between automated intelligence, which means completely automate the task, like self-driving, versus augmented intelligence, which means human and software working together. And even self-driving, the initial deployments of self-driving is actually not automated intelligence, it's augmented intelligence. It's mainly been deployed for industrial trucking. So you have someone who actually is sitting at home or an office, and they're driving like a video game. There's cameras on the truck and so on the lead truck. So basically, he is driving or she is driving a truck from their home like a video game. And there's cameras so they can see everything going around them, and there's a lot of software sort of figuring out what to do. And then there's a line of trucks behind the lead truck that just follow the truck, and there's no humans in those. And so the cost of labor is much lower. And one of the problems with trucking is these truckers drive a long way, and they're paid by delivering on time, so they tend to stay up too late, driving when they're tired, sometimes taking drugs to stay up and so on, which is very bad for many reasons. And now you can switch a driver every 2 hours because it's just a video game, right? And you can just switch who's driving from office to office and so on. This is an example of augmented intelligence. So it's not only very complex things like physicians that can be augmented intelligence, it's other things as well. Right? So we need to think about those opportunities for how we are coexisting the software and the human. So I'm going to suggest to you, and I'm really borrowing from this guy, Jerry Kaplan, who's like a futurist, AI doesn't put people out of business, it puts skill sets out of business. Certain skill sets, which are very narrow and can be taught and are very repetitive, like driving a car, putting your foot on a brake and changing lanes, this is very repetitive stuff. AI is very good at these kinds of things. Right? Those will go away, right? But there will be other things that emerge, just like when they automated all the factories, people, all these jobs, what are these people going to do? And all worried. The reality is we had no problem figuring out other more interesting things for those people to do and safer things for those people to do, by the way. So we'll have to go through another generation of that. I don't think we figured it all out yet, but we need to start thinking about it, right? And that's the purpose of this discussion. So one of the interesting aspects of using AI is that if we use math to make decisions, will we eliminate bias? The example I would use is if you go to a bank and you ask, in the old days, the bank manager, please give me a loan because I want to buy a new house. It used to be a very subjective decision. I remember as a kid, my parents, they dressed us all up in our best clothing. They took my two brothers and I, and we as a family had to sit in the office of the bank manager, and then he asked us questions. And I remember my parents scaring us, you have to be on your best behavior, because if you misbehave, we are not going to have a house to live in. And so as little kids, we're, oh my God. And then the branch manager is interviewing my parents to see does he or she, and it was mostly he's, because there's a lot of bias there in the workplace, right? He was usually an old white guy making a decision about whether we're going to get a mortgage or not. We have to be on our best behavior. But if you are, for example, a single female with a family, and you go in to ask for a mortgage, your likelihood of getting the mortgage is less than if a single male with the same qualifications and the same kids has. And I can make the same comparison of if you're white or if you're black. Right? So there's bias in this subjective decision making. So one of the advantages of using AI machine learning to drive decisions is we can get rid of this bias. Do you believe it? Are we going to get rid of bias by using machine learning? Yes, we are going to get rid of some of it. But it's not going away, and this is something very important to understand. Because people believe, now the computer's making it, we're safe, the decision's going to be a good one. It's not completely true. Because data scientists introduce bias into the algorithms. And again, it's our responsibility, because we're practitioners, to not let that happen. Now, I am not saying the data scientists purposely put in the algorithm, if this person is female, don't give them a loan. If the person is male, do give them a loan, or white or black or brown or whatever. No, I'm not saying that. But the bias sneaks in ways that you may not be aware of, right? So the good news is that AI is very good at sort of recreating the decisions that humans make. So we can put in all this information about how long you had your job and what is your salary and all these kinds of things. What is your disposable income relative to the mortgage repayments? And we can mathematically create a probability. This is the likelihood this person will pay back their mortgage, so we do or do not give them a mortgage. So that's great. But we're also good at recreating the bias that exists. And that's the problem. And I'll talk about where that comes from. So we can understand and manage these biases. If we're aware of them, we can start to manage them. So proactive management of bias is very important. We should not assume that it's not there. Just because machine learning is doing the job, we say, okay, we're done. No, you have to actively manage this. You have to look at the output of the decisions. You have to measure and look to see, are you getting more false positives and false negatives aligned to a particular community by religion, by gender, by age, by ethnicity? We need to measure all of these things and proactively manage. Right? So the World Economic Forum would argue that the number one impediment to widespread adoption of AI is built-in bias. So we know this is a problem. You will largely see AI being used today, machine learning and deep learning, for marketing kinds of things. I will make a better recommendation to you of what to buy. And this is not highly regulated because nobody really cares what ad you get, right? Although it can be unfair, right? Why do I get the discount and you don't get the discount? So there can still be some social injustice there, but it's not the same as I get the mortgage and you don't get the mortgage, right? That's a higher impact on your life. And today, machine learning is largely not used for doing risk scoring, even though we can prove that it works very well, because it's hard to regulate it. And one of the things that we'll talk about is our goal for using AI is not just to get better decisions, is to get more fair decisions. And we should be able to audit those decisions, which means that as important as accuracy of prediction is explainability. Why did you make this decision for me and a different decision for you? We need to be able to explain that. And so a lot of the universities now are shifting their focus from the best AI deep learning algorithm for accuracy to more explainability. And I'll actually trade off to get less accuracy if I can get more explainability, because then I can start using it for decisions that I'm not allowed to use it for in today's world. In fact, IDC made a prediction that there's going to be a huge backlash against AI. 10%, their number, of consumers will say, I don't like AI, get it out of my life. I don't perceive it as fair. I don't understand it. It's like this black box. But I don't feel like I'm being treated fair. And 10% is a big number. But if you remember the Occupy Wall Street movement, that was like 2%, right? So 10%, and these are not quiet 10%, these are loud 10%. They make a lot of noise, and this is why World Economic Forum believes that this is the fundamental, right? Explainability and fairness is fundamental to the success of this technology. There are already a lot of laws around, bias in AI. So it is illegal in New York City to use AI algorithms that have bias. I will tell you this is a completely useless law, because how do you enforce it? The lawmakers can put it, it makes them feel good politically. I put this there, I'm very visionary and so on. But if you don't tell me how to enforce it, who's gonna figure out if there's bias there? We need another AI algorithm to check the bias on the AI algorithm. And who's gonna check the bias on that algorithm? We can make it illegal, and we have done in GDPR and CCPA, and most countries have some kind of law that makes it illegal, but there's almost no enforcement, because how do you know? How do you know? So my claim is mathematics are not biased. Math is math. In most cases, data science is also not. The data scientists themselves, they're not biased. Most data scientists are not trying to introduce bias because they don't like some community, right? The real problem is the data. So you inadvertently introduce bias through the data that you use for your training set. It's very hard to get diverse training sets. One of my favorite examples, because it's very ironic, is Nikon cameras. They're a very famous, very good camera manufacturer. And these cameras have a lot of software in them. And one of the things in the Nikon camera they have is blink prediction. Right? Now, who makes Nikon camera? Japanese, right? It's a Japanese product. Right? So this blink prediction, when you take a picture of your family and somebody's blinking, the picture is ruined. So the camera will say, somebody in the picture is blinking, take it again. This is very useful. Now, the ironic thing is that this software has a bias that for people of Asian descent, Japanese, Chinese, Koreans, and so on, it has a lot of false positives, because the eye shape of someone from Japan is different than the eye shape from someone in the West. So where did they get the training set? Probably this algorithm came from Silicon Valley. The training set was not diverse enough from an Asian point of view. You probably had lots of European, right? Because that's largely in Silicon Valley, European and Indian, right? That training set will be very good. But if you don't introduce diversity in the training set, you build in bias. So they had false positives. They're telling you to take more pictures of your Japanese family because they can't actually tell if you're blinking, but they can tell if a European is blinking. This to me is ironic, right? And so it's not done on purpose, clearly. Right? And the bias does not originate in the AI algorithms. That's just math. It's in the data. And you say, oh, no, don't worry. I'm a good data scientist. If we have a mortgage repayment prediction algorithm, I will make sure that gender is not one of the features that I'm using in my training set. So we will not be biased against females if we don't have gender as a feature. I will not have race as a feature, so we will not be biased against black or brown, against white, and so on, because it's not there. So we can eliminate those features which are source of bias. You're fooling yourself, because the AI training algorithms are very smart. I know if you're male versus female based on your clickstream data. I don't need a gender flag. You click very different if you're male and if you're female, in 99% of the cases. You click very different if you're brown versus black versus white. You click different. You look at different things. It's normal. It's cultural. And so you have to be very careful that these biases do not sneak in based on correlation that's in the data. correlation of your behaviors with the feature that is, is gender, ethnicity, and so on. Does that make sense? All right. So that's why you cannot assume that because you're an ethical data scientist and you didn't put those features into the training set that it's not there. Correlation will find those features whether you like it or not. So we have to proactively manage to make sure that we're not introducing bias on that basis. Where does bias get introduced into AI? First thing is how you frame the problem. What is the objective function of your machine learning? Let's take a song recommendation algorithm. Many of you probably use these platforms that can recommend you songs and so on. You say, what mood am I in? I'm in a happy mood. I'm in a romantic mood. I'm in a fast driving mood. And so it will then play songs for you, right? And you think that the algorithm is designed to play the song that you would most like to listen to at this moment. You are so confused. Because this is a commercial business to make a recommendation. And they have to pay royalties to the song maker. And the royalties can be different for this song and that song. So is my objective the song that you most want to listen to? Or is my objective the song that has the lowest royalty? The reality is it's a little bit of both. So you have multiple objective functions. I want to play a good enough song that you will not turn it off, but the lowest royalty possible. And so that's why transparency and explainability is important, because as a consumer, I want to know, what is this recommendation really based on? Is it in my interest or is it somebody else's interest? If they're recommending a product because that product has the best margin, so if you're on an e-commerce site and they're recommending a product and they're optimizing for their profit, that's not in my best interest. It means I should keep looking. I don't take the recommendation. I keep looking for the one that meets my criteria, not their profit criteria. How you collect the data. I gave you an example for the Nikon camera example, but there are many examples. Let's take the song recommendation. I could decide that I don't like songs that have bad words in them. So I eliminate from the training set all songs that have, in the US we call it, the 7 words you can't say on radio, right? So there are 7 words, I'm not going to repeat them, right? 7 words you should not say. And so I'm going to eliminate all those songs from the training set. I've just become the censor. I'm now dictating that you can't hear songs that have a bad word in it because I've decided on your behalf the bad songs, bad words are not good. So I would argue that's not the right thing. Or at least if you're going to do it, you should be transparent about it so I can make a decision whether I want to use your recommendation or somebody else's who doesn't do that. Right? And how you prepare the data. How you collect the data. What is your sample set? Right? Are they a bunch of white males between the age of 20 and 30, or is it a diverse sample set? And what about outliers? Do you handle the outliers by throwing them away, or do you include them? Because outliers might be from a different demographic. So we need to pay attention to these things as we're collecting and preparing the data. In academia, there is a working group that's been created called FAT. Fairness, accountability, and transparency in the context of machine learning. That's just mostly academics, and they're really thinking hard about how to create more transparency, how to eliminate bias, and how to create more explainability, which is really transparency. If you want to read a book that talks about these issues, I would recommend this one by Cathy O'Neill. She's a brilliant mathematician, but she's also kind of an AI activist. So she talks about how these biases get introduced and how we can sort of prevent them. And she uses real examples like how people in prison get paroled differently if you're white or you're black. Right? And in the US, this is a big problem. Right? And there are many of these kinds of examples. And she's taught it at UC Berkeley and Harvard, and she's very accomplished. She's a very good writer. It's a fast read, and I would definitely recommend it. Weapons of Math Destruction. Right, this is the name of the book. So I've tried to give you kind of a balanced view of good and bad of AI, right? And if I look at kind of future of AI, I believe it's going to be part of our life, right? It's going to be there. And as practitioners, we have a responsibility to make sure it's used well. Some people say, no, get rid of it. This is what this noisy 10%, just get rid of it. This is just being in denial. This is like the people in the Industrial Revolution in the UK, in England, where they were automating the looms for doing textile, and the workers revolted and they threw all the looms out the window and crushed them all and so on, because we want to do it the old way and preserve our jobs. What happened? In Germany, they introduced the looms and all the textile business went to Germany, and those people are out of a job anyway. So AI is a reality, and AI is not going to replace managers, but managers who use AI will replace managers who don't. So you got to figure out how you're going to use these technologies in a productive way. So my recommendations to you are create a standardized approach for developing the model. And data scientists sometimes don't like it. They say, I'm an artiste. I want to be able to do things the way I want to do. I want creative freedom and so on. The problem is if there are no standards, there's a lot of opportunity to introduce bias in how you collect data and how you measure and so on. So I'm not trying to reduce the creative juices of the data scientist, but I want some processes in place to make sure we're collecting data properly, to make sure we're not using bad features in our training set, to make sure that we're measuring the performance of the model, not just predictive performance, but the built-in bias of those models, right? So we should identify our prejudices that really come from the humans, not on purpose, but I have a bias. I know I can get this great training set from Stanford University because a bunch of students in there participated in some study. We got a whole bunch of training set. Are those Stanford University students that participated, are they an accurate reflection of the population that you're trying to build this machine learning model for? The answer is dubious, right? Because Stanford University students are a very kind of unique group of people, and you can't assume that that extrapolates to the people in the general population, right? So we need to understand those prejudices. We need to test for unwanted biases. We need to invest in explainability. And on our data science teams, I like to have one person who's the designated challenger. The person who says, I don't believe the algorithm works without bias, and I'm going to test it. Because when you have a team working together, you get this effect called groupthink, and they're all trying to build the best model and so on, and they're all very proud of themselves, and it's good. You should be proud of yourself. And there's something called confirmation bias, where they find something and then they believe that it's true, and any data they see that doesn't align with their version of truth, they throw it away. So I want the challenger who's going to make sure that kind of thing doesn't happen. So with that, I thank you very much for spending this time this morning. And I'm happy to answer any questions or have some discussion on any of these topics.
Is the data quality, the data that's going into the AI model?
So the question is, how important is the data quality of the inputs for the training sets and the scoring and so on? I would say it's very important, but if you wait till you get perfect data, you will never do anything. So the reality is, as long as there's no systematic bias, you can use deep learning. Actually, one of the things deep learning is good at is tolerating imperfect data. That's one of the reasons it's better than the linear mathematical algorithms, which are not very good at tolerating missing and dirty data. But systematic bias can be a problem. So for example, if you ask on a form or an application, what is your weight? Males will generally fill it out, and females won't. And so that can become a correlation source and say, so people who don't fill in their weight, we treat them differently than people who do. And there's also built-in bias. If you ask a male to fill in their height, they almost always exaggerate it by a couple of centimeters, right? So we know that those things happen, and you're not going to fix it. But the deep learning algorithms can actually, they will learn that those biases are kind of built in. and you need to make sure that they're learning in a way that is aligned to this objective of no bias and so on.
So how is explainability and accuracy of data a trade-off?
So the question is, what is the trade-off between explainability and accuracy of the model? When you start getting into very complex models, let's say, for example, using deep learning with multi-layer neural networks, if you don't have a PhD in data science type of technology, it's very hard for you to understand what's going on there. So if you have a linear mathematical algorithm to predict, someone who has, sixth grade or let's say seventh grade math can understand that. It's just, coefficient factor, and we can see, is it positively weighted or negatively weighted? So linear models are relatively easy to explain. But these much more complex ones, which are more accurate, are very difficult to explain. And so there's a pretty big trade-off. And I'm not saying we should use linear algorithms for everything, but when there's not a big difference in prediction, use the simple one that's explainable. And these multi-layer neural networks, there's a lot of research going on in academia at University in Toronto, in Waterloo, in MIT, and Stanford, focused on how do you create, and Cornell, how do you create explainability even for this very complex mathematics? So there's something called Shapley, which is actually open source. And you can take that mathematical algorithm, and actually the code is posted in open source, and you can start to use that, and it'll explain in relatively simple form what's going on in the neural network. So as the explainability algorithms get better, the trade-off becomes less severe because now we can start to get some understanding. But this is a very active area of research right now.
Unfortunately, majority of the companies that are sitting on trillions of bytes of data are the companies that are monetizing it one way or another. So how do you, going forward, how do you disincentivize those companies from not introducing monetizability?
Right. So the question is, how do we disincent monetizing data? But I'm going to change the question a little bit, because I think monetizing data isn't really the problem. I think we should be monetizing data. It doesn't mean that I'm giving my data out, but I want to monetize the data. That's kind of the point. What you have to be more careful about, which I think is in between the lines of what you said, is someone becoming a monopoly owner of the data, which is unfair, right? So I think that we need to have appropriate policy around making sure that multiple people have data, which they collect in different ways, right? So, for example, telecommunications companies have a lot of data about your behavior, and most of them are pretty unsophisticated in how they use it. I think they need to become more sophisticated. And some of them are making the investments to do that, and some of them aren't. And you can take the data from a telecommunications company, and you can start competing with Google. They have different kind of data, but that's okay, right? So I work with a company in Europe, and this company, this country, Czech Republic, does not have a credit rating bureau that's reliable. Like in the US, all the banks pool their data about payments and so on, and you can get a credit rating pretty accurate. In Czech Republic, it doesn't exist. The most accurate thing you can do to predict someone's credit worthiness is look at their prepaid behavior on a mobile phone. How often do they top up? How much do they top up? Do they run at just the balance? So we can build these models, and the telecommunications companies actually, they spun off a separate company, which is a credit bureau. And there were 3 main telcos, and basically if I want to sell you a car, I get your mobile number, I submit it to this credit bureau, and then it gives me a score of what is your likelihood to pay back this car loan. Right? I'm oversimplifying it a little bit, but that's based on the telco data. Now, these 3 telcos, they do not share the data. The credit agency is really a shell company, and based on the mobile number, they know, is this Vodafone, is this T-Mobile, is this Telefonica, and they will send it to that company. And then they do the score locally on their data, so the data is never intermixed, but all three of them use exactly the same algorithm. So it's fair across the different providers, and then they come back. So that's monetization of the data, and I'm all in favor of that. I think that's a good thing. And maybe Google can figure out a credit rating based on what you search for and what you click through. I don't know, but they haven't done it, right? They probably could. So I want to encourage that kind of creativity, because the telcos are actually doing something good for the society of allowing people to get loans that maybe wouldn't have gotten loans before.
When you spoke about bias, I mean, do you need to have that control through processes, or do you need to deploy separate algorithms to measure bias?
The answer is both. So you certainly need to have well-defined processes to try to reduce the bias in how we collect data and things like that, including the sample size. You were talking about the importance of sample size. If you have too small a sample, then you lose diversity for underrepresented groups, and then bias gets introduced for those people, for example. But in addition, I would argue, you should also measure. You should look at, okay, all those mortgages that I gave, how many people actually paid back and didn't pay back? And are you getting more false negatives, meaning that you said the person wasn't going to pay back, but they did? Well, that's tricky, because you can't have those, right? Because you didn't give them the loan. So then you have to look at the false positives. Are we getting more false positive where I said, the male, we thought they were going to pay back the loan, and the female, we thought they were going to pay back the loan, and we have more false positives of males who didn't actually pay. That means we're introducing bias to the females. So you can measure after the fact, and we should measure, right? So we can make sure to recalibrate the models and make sure that no one community is being biased against.